Hello everyone, let's see the question. An ideal gas enclosed in a vertical cylinder supports a freely moving piston of mass M. The piston and cylinder have equal cross-sectional area A. When the piston is in equilibrium, the volume of the gas is V0 and the pressure is P0. The piston is slightly displaced from the equilibrium position. The reason that the system is completely isolated from its surrounding. The piston executes a simple harmonic motion with frequency. Okay, so in this question you have to find the frequency. Now just look at these options. All these are dimensionally different. Okay, these all are dimensionally different. Okay, now you can see that this frequency, you have to find the frequency. The frequency is given by 1 upon second or 1 upon time period. So whichever is giving you the formula for 1 upon second, just go for it. Okay, now look here, first look at this first option. Now first option is saying 1 upon 2 pi is constant and this gamma is also constant. Here gamma and 1 upon 2 pi, both of these are constant. Oh sorry, not constant, sorry, dimensionless. More appropriate is dimensionless. Okay, they are dimensionless. Now look here, V is the volume, so that means volume is given by meter cube. M is the mass, that means kilogram. P0 is the pressure, pressure is given by force per unit area, or you can say this as mass into acceleration upon area. So here we can write it as kilogram meter per second square, and for area 1 upon meter square. Okay, and now this is divided by a square, that is meter square, and gamma is dimensionless. So now we can see easily that this will be cancelled out and this will become only meter, this will be cancelled out, but here we got it as kilogram square upon second square. So this option is not fitting to our frequency dimension, so that means option 1 is not correct. Okay, now let us look at the option 2. Here it is, we 1 upon 2 pi is a dimensionless. Now upon under root, that means raised to the power 1 by 2. A square, that means meter square to the square. Gamma is dimensionless. Again, its P is the pressure, P0. That means force into, or force upon area, and force is what? Mass into acceleration, and mass is in kilogram acceleration meter per second square upon area. That means 1 upon meter square, and this whole is divided by mass kilogram, and then V0 is the volume. So this will become meter cube. That means this will be under root m raised to the power 5 kilogram upon meter square second square kilogram meter cube. Okay, so now these will be cancelled out, kilogram is the cancel out, and 1 upon square root, this will be 1 upon s, and which is the dimension of the frequency. That means option 2 is correct. Okay, now if you want to check these also, 3rd and 4th, they will be also found as dimensionally incorrect. But if you have seen that they are, or you can just go for further it, like now just see the 3rd option, mv0, m is the mass, that means kilogram meter cube upon area is meter square. This gamma is a dimensionless quantity. P again, that kilogram meter per second square multiplied by 1 upon meter square. So we get it like this here cancel out, this is here square, kilogram is cancel out. That means we get here we get meter square upon second square under root, that means meter per second. So this is not coming as the unit of the frequency, so this option is also incorrect. Now let us move to the 4th one. This 4th one is like A is the area, that means meter square. Gamma, it's again dimensionless. P is the pressure, that means kilogram meter per second square dot 1 upon meter square, and whole upon meter cube and kilogram. So this kilogram will be cancelled out and this meter square is cancelled out. So we get and this is also, and this will become meter square. So we get it as 1 upon meter square and second square. Again, this is not also satisfying. So that means this option is also incorrect. Only the correct option we are getting it as second. So option 2 is the answer. You can just see it from the dimension. So option 2 is correct. So I hope that you understood this. All